all for coming tonight. I spend most of my time professionally, I just spend most of my time doing business intelligence architecture work, and I'm an independent consultant. I've had my own company for a number of years, but I've been independent. Intelligent Business is the name of my company. I also work with CSG Pro here in town on a contract basis, but I was happy to join their team and work with some other folks who I've actually known and worked with in the Portland area for many years. And you know, we've really seen a shift in the industry. I've been doing BI work, kind of depending on what you count, for somewhere between 15 and 20 years. Reporting services, analysis services, semantic modeling. And you know, 10 years ago, 12 years ago, if we talked about the definition of business intelligence, it was pretty cookie cutter. SQL Server, dimensional model, maybe cubes, and then some reports and dashboards using various tools. And in the past few years, we've really seen a shift to a lot of emerging technologies, cloud-based technologies, big data, you know, very more unconventional ways of storing and managing and streaming data, a lot of different ways. And working with students, I've been kind of working in a mentoring role with Washington State University. The message that students are getting is that data is big data, and data is analytics, and data is streaming, and data is all of these different things. The story's not so simple anymore. And I'm going to talk about that and kind of talk about what that means and maybe what it doesn't mean, what might be a distraction and what might be kind of a game changer. So we see patterns in nature. So, you know, we look at the world around us and you can see that plants have patterns, and the way that things grow are patterns, and you know, there's some very natural patterns in the world. And if we kind of go back in history a little bit, there were smart people who recognized that there were patterns to things, that things occur in nature. And one of these people was a gentleman by the name of Leonardo Pisano, also known as Fibonacci. Fibonacci figured out that in nature that there were simple mathematics and simple sequences of numbers that can be found in nature and can be used to create some very elegant, very simple things. And so we look at the Fibonacci sequence, which is a very simple sequence of numbers. It essentially just says that if we take a sequence of numbers and add them up and then take the result of that result and repeat the pattern, that it creates kind of this spiraling, very elegant equation that can be used to create all kinds of interesting things. We can see that in nature, nature has figured out that there are sequences, and it actually applies this very simple pattern. Now, is Africa actually a result of the Fibonacci sequence? I think sometimes when we go looking for things, we might find them, where I don't know if the continent of Africa was actually formed or somehow created from a Fibonacci sequence, but somebody observed that it looks like it did. It's interesting to observe. It's kind of hard to say, well, yeah, that's a pattern in nature, or it's not. But applying the Fibonacci sequence, we can actually do some simple math and create other shapes and derive geometric patterns from this very simple sequence. My point is that this is a pattern. It's a natural pattern. It's something that someone observed and then found a way to apply in science to be able to kind of repeat and be able to create things. Well, there are also patterns in data. And I'm a firm believer that data is about patterns. Now, what's data? Data is really just information. We're just capturing things in the real world, whether it's about people or financial transactions, or I'm working with legal cases right now with a large court system. And you know, as we gather that data, capture that data, store that data, process and analyze that data, there are some natural patterns to the way that data can be stored, the way that data can be used. Sometimes those patterns may seem to be somewhat chaotic, and sometimes they may seem to be very orderly, depending on how we're going to use that data and why we capture and store it. Well, there was a gentleman in the early 70s who figured out that there should be, and whether they're naturally occurring or created by humans, that there should be rules and patterns to the way that we manage our data. We were chatting on the way here, and Bob, who's new to our group, actually attended a presentation that E.F. Codd presented. Where was it?
It was in Seattle. It was MicroRim.
Okay.
And
when was it?
It was in the 90s.
Okay. All right. So we all know of E.F. Codd. We know the Boyce and Codd normal form and the rules. What's interesting, and I've done some reading, but I don't profess to be a renowned expert on Codd's principles. And he and his associates from Oxford and gentlemen who worked for IBM in the early days of relational database technology, but Codd tended to kind of go deep into the rules, and so he came up with 12 rules. I'm just going to read this because I didn't make this up at all. This is out of Wikipedia. It says, Codd's 12 rules are a set of 13 rules proposed by Edgar F. Codd, a pioneer of the relational model for databases. So he was such a geek that he started with 0 and decided to make them 12 rules, but there are in fact 13 rules. I'm not going to read through Codd's rules, but Codd was kind of the opinion that there should be a rule for everything, and that's why there were so many. When he teamed up with Boyce, they essentially said, let's simplify this. Let's make it a little more palatable and distill this down to maybe 5 rules. We'll do first normal form, second normal form, third normal form. They said, okay, well, third normal form wasn't good enough, so we're going to make Boyce-Codd normal form, which some people refer to as 3.5 normal form. Regardless of the details, it's just a simple set of rules that essentially say, you should put the same kind of data in each column. A row should be uniquely identifiable, and there should be relationships between rows. These are the essential building blocks of relational databases. All right. Well, this is one of my heroes. And this gentleman recognized that there were patterns to the way that we manage transactional data for the purpose of managing inserts, updates, modifications, as well as the way that we read data. But when we think about reporting, and typically analytic reporting, it's not so important to optimize our data structures to manage transactions. In fact, there's a lot of overhead. There's a lot of unnecessary baggage that we typically have to architect into a database when we have to manage transactions. And so Kimball was a little disruptive in his day, and he stepped back and he said, normal form's a good idea, but we want to simplify. We're going to talk about simplifying tonight. So Kimball came up with the Kimball method. He wrote a series of books. The most notable was the Data Warehouse Toolkit, which I consider to be the Bible of analytic design, data warehouse design, and what we call dimensional modeling. All right. Well, there were other ideas in the industry. Bill Inman was often kind of, I think Bill Inman called himself the father of data warehousing. Kimball was a little more modest in his presentation, but But Inman took on the title of the father of data warehousing. Notably, Kimball and his consulting group down in the Bay Area did their thing, wrote their books, went out, did consulting, kind of hung their shingle, and were well known for the dimensional model and the way that they architected data warehouses. And then they brought their company to a conclusion in 2015 and said, that's it, we're retired. We're done, we made our money, we're all on vacation. Inman, semi-retired, still writing some books. I picked up a book that he wrote about data lakes and been doing a little bit of reading. So he's still in the game, but you know, he's on in his years and not as active in the community. Generally speaking, Kimball's idea was that we start with subject areas and build data marts, and then we build data marts that are kind of associated with each other, but we kind of break the problem down into pieces. Inman generally says we need to step back and think holistically about the data warehouse, architect the whole thing, do a lot of diligence and work very hard to gather requirements and understand the scope of the data warehouse, architect the data warehouse, and then we can think about distilling it down into subject areas. So it was kind of a big picture, smaller picture juxtaposition, but generally speaking, these two philosophies are fairly congruent and compatible, even though there are some different ideas. Okay. In the modern day, we have a different approach. Lawrence Core wrote a book about agile data warehouse design. And I've been working in BI for, you know, the past 15 years or so, and working on a lot of projects managed by people who are used to developing software. And you know, back in the day, we would think about monolithic applications that were done in a very waterfall-ish approach. You gather all the requirements, get everything up front, shut the users out, shut the stakeholders out, go dark, build the thing, deliver it in a year and a half, and find out that the requirements had all changed. And then the pendulum swung the opposite direction, where it was all about agile. We'll just work in 2-week sprints, and yeah, we'll get some sense of requirements, but we know the requirements are going to change, so we're going to adjust and make things up as we go. A lot of good to that, but there's some trade-offs as well, because it's easy to lose sight of high-level requirements. So Core's whole message is waterfall is good, agile is good, we need to do little waterfalls. And we need to maintain the big picture and the large scope, and we need to do agile. Agile's a good thing when it's adjusted to work with BI. And it's a good idea. Core's ideas are this. Again, waterfall has some credence. Agile is a good thing, but we need to understand what you lose and what the trade-offs are when you're implementing Agile. Waterfall, iterative, both have some good elements to them, but business intelligence and Agile data warehouse projects usually require some kind of a blended approach. All right. So in my mind, these are really the two books to pick up if you want to be good at data warehouse design. I believe this to be the Bible. I think that it's as true as it's ever been. I think that Kimball was right. I think that Kimball is still right. But in the modern day, we have to think about the way that we design solutions a little bit differently. The pace of business is different. The way that teams work and the discipline is a little bit different. And that's where I think that thought leaders like Core have been able to take a lot of these principles and modernize them and make them a little more pertinent in the modern age. So his ideas really boil down to some simple concepts. It's a thick book, but in simple terms, he applies what's called BEAM technology, which stands for Business Event Analysis Modeling. The idea is that events occur in business, and we think about modeling for events and mapping our development strategy to these events. He also promotes the 7 W's, which are really just the question words, you know, who, what, where, when, and why. But that's part of the discipline of gathering requirements, challenging requirements, engaging stakeholders, et cetera. He also talks about this idea of model stormers and identifies 12 different stakeholder roles and personas, and essentially says that everyone has some value, whether it's just a business stakeholder or a developer or a DBA or somebody in between. Breaks that down and kind of talks about how those personalities align and how those people can work together without getting into details. Yeah, so let's talk about the kind of the tenets of dimensional design. So how many of you have experience with dimensional modeling and have worked through building data marts and data warehouses? Okay, so a good third, maybe a little less than half the people in the room. How many of you work with transactional databases primarily? Okay, so you know, when we think about modeling a transactional database, I've been working on a project for the Los Angeles Superior Court. And you know, so that's kind of what I'm immersed in lately. And the goal with the court, they started using Power BI. And like a lot of big organizations, you know, they've been working with large dimensional databases for a long time and have experience with things like crystal reports and reporting services. But in their world, when a user wants a report, they write up this very formal report request. They call it an ECR, and I can't even remember what that means. But it's this formal request that says, I want a report that has this information. It's grouped by this, filtered by this, and you know, this is sort of how my report should look, and I want it in Excel. And you know, so whatever it is, export it to Excel. And so the ECR comes in, and the database person gets it, the report modeler, and the database person and the report designer sit down, and the end result is that somebody writes a big gob of SQL that joins 13 tables together and spits out a bunch of rows and columns. And then the report designer groups and filters and creates this grid. And that's a report. And they decided to start using Power BI. And so they put Power BI in the hands of some business people, less technical people. And they're out modeling their data and creating some reports. And that's gone relatively well. But now they want to govern it. Now they want to rein it in so that IT can manage it and they can work with the users. And that's where there's really a difference of opinion. And this is happening in businesses all over the place. So if we start with, and I'm not going to break down their database design, but those of you who are familiar with transactional databases know that it's very common for you to have hundreds, if not thousands, of tables that have lots of different relationships that really exist for the purpose of managing transactions and making sure that every single record can be traced, that when you update a record over here, there has to be a related record over here, et cetera, you know, conforming to the rules of normal form. But when we design for reporting a database, and this is only one subject area, by the way. This database called Odyssey has literally thousands of tables in it. But the reporting structure, I'm showing it to you in Power BI because that was really our modeling tool. And we're working on the SQL Server Data Mart version of this, but it's on their servers and I don't have access to it in this setting. But as you can see, this data model, compared to the other, is actually quite simple. And there are only two tables that I would consider not to be lookup tables, and they're the case header and the case assignment history. Everything else just supports cases. Okay, so what am I talking about? I wanted to actually show you what my work environment was like when working with the Los Angeles Superior Court. And I realized that I didn't have this picture, so I've emailed it to myself and I forgot to open it. So I'm not going to sit and wait for Outlook to open, but I'll go back to that. But you think about a large court system. So the Los Angeles Superior Court is the largest court system in the world. What do they do? What do they manage? Well, they have jurisdictions, they have courthouses, they have judges, they have attorneys, lots and lots and lots and lots of attorneys. That's the largest table, by the way, other than the actual transactions, the actual assignment history of the attorneys. And then you have parties. You have case parties. So you have plaintiffs and defendants and, you know, minors and parents and people who are involved in cases, people who sue each other, people who get sued. And so really at its core, it's very, very simple. I have a case, and that case is assigned, you know, it's in a jurisdiction at a courthouse, and it's assigned a judge, but over its history, it can have different judges, and then different attorneys and different parties. So all of these tables are simply supportive of those what we'll call fact tables. So as we think about designing a data mart, a reporting structure, I'm going to kind of step back and whiteboard this a little bit.
Excuse me, that first diagram that you showed, the gigantic one, that has no relationship to this one at all, right?
That is actually a diagram of the source data that was derived to create the data model that I showed you.
Okay, so you took all that and you pumped it into your warehouse and you made it real simple.
Right, right, yeah. And I thought this was kind of funny. The entity relation diagramming tool, can you see what it is? It's Excel. That's the output from this essentially this case management ERP system that the court uses. Within their tool, they export the ERD and it pumps it out to Excel, which just makes the point that Excel is the center of the universe, right? So we think about, you know, about being able to deliver on report requirements. Everything's associated with a case. So I'm going to say, okay, I know that I need a case. What do cases have? Well, they have counts. So I have case count, number of cases. I have the cases that are disposition, the cases that are closed. I have the cases that are assigned. So I've got all kinds of counts and numbers and metrics associated with those cases. Let's not go into detail, but I have some measures associated with cases. And the kinds of things that they keep track of is, you know, what is the caseload for a judge? How many new cases were assigned? How many cases did a judge disposition? What were the disposition of, or the status of these different cases? How many were transferred, you know, in or out? And then what fees were associated with various cases? So what else do we have associated with a case? Well, we have an organization, and with this data, the organization was actually fairly complex. It's a 9-level organizational hierarchy that starts with a jurisdiction like Los Angeles Superior Court. You know, they work with other courts. So we've got Orange County Superior Court, District Court, et cetera. And then those jurisdictions have courthouses. And so, you know, courthouses have rooms and have departments and et cetera, et cetera. Somehow that all breaks down to a 9-level hierarchy. Hierarchies are very common when working with report data. There are other things that may be represented by hierarchies. Organization, leadership within an organization, geography can also be a hierarchy. This is not a heavily geographic database, but oftentimes we'll see, working with, for example, KinderCare last year, they have all of these centers all over the country, and they start with districts, and they break down into regions, and then they have centers, and centers have different disciplines, and they had a very, very deep organizational geographic hierarchy. What are some other things that are hierarchical that you've worked with? Dates, okay, dates have a natural hierarchy. Okay, you know, year, semester, quarter, month, week, day. What else? Jeff, what's hierarchy? Hierarchical. What's that?
Parts breakdown.
Okay, parts. So we think about components and parts. Sure, you know, if you're working at Boeing, you know, you airplane, wing, assembly, blah, blah, blah. I'm thinking about a chart of accounts.
Sorry, I was writing.
Yeah, I know. That's not the first time I've called you out in the middle of a meeting, is it? Right. So an accounts hierarchy, also very common. Date dimensions. So anytime I encounter a date, there's a good chance that a user will want to be able to say, for my transfer in, I want to know what cases were transferred in a certain month, as opposed to transferred out. I've got another date in here, and I've forgotten what it is. Transfer in, transfer out, can't remember. But anytime we encounter a date, oftentimes what we'll want to do is build a separate table. Yeah, reporting date was actually a special thing, and that's why this is a disconnected table. Essentially, that's my effective date. I want to say, okay, I want to see all of this case history, but I want to see what it was as of a certain date. So I don't necessarily want to slice the table. I want to use that in a calculation, which is a little bit of a special case. So, there's a very specific process to looking at the reporting requirements and saying, okay, how do I want to filter or group or view my measures against things like a case category, a location, a judge, an attorney, a party. Any of these things would be stored in dimension tables. And those individual location or name, or in the case of a date, a year, a quarter, those are attributes, which are fields of those dimensions. Yes?
So I see you have a relation between two, like, basically fact tables. My understanding is that's kind of like sacrilegious if you're treating Kimball as your Bible.
Well, and true, I agree, and so there we have theory and reality. And I think that this is not a true dimensional model. I'd say that it's a hybrid model because we have a header detail association here, which for this data is a reality. Now, I could take the header and I could duplicate it and just put it into a single fact table. But it's tools like Power BI and Tableau and Click that I think have helped us understand that pure dimensional design, where you just have fact tables and dimension tables, maybe some bridge tables, but pure facts and pure dimensions doesn't necessarily answer all of the, deal with all of the requirements. It doesn't answer all of the challenges of analytic reporting. And so yeah, this is not a pure dimensional schema, but it does solve the problem. And so, but I'll go ahead and wrap up. Okay, so this has been a fairly high-level overview of some of these concepts. But we talked about business facts and dimensions. We talked about hierarchies a little bit. One of the things about hierarchies is it gives us the ability to drill down and to drill through in our data. It gives us a navigation mechanism, which allows a user to look at the data at a macro level all the way down to a micro level. One of the lessons that we've learned in business intelligence is that you can store transactions in your data mart, data warehouse, and you can surface them through a model so that they're available to reports. That was always a big trade-off, but we have the technology now that really allows us to get down to the transaction level, so we no longer really have to see a data warehouse, data mart, or semantic model as this trade-off where we can't see details anymore. But we have the technology, we have the storage space to be able to do that now. Talked about measures a little bit. We could spend a lot of time talking about KPIs and key success metrics, but really that's how we answer business questions. Yes? Drill down means that within my reporting experience, I'm going to start at a higher level. Just for simplicity's sake, let's say we go from year to quarter to month, where drill through means that I'm navigating from one report to another. Maybe based on the same model, could be a different data source altogether. But essentially, the user goes down to a certain level. They're looking at a value in aggregate. They click on something or use some feature of my reporting tool that then takes them to the details for that filtered view of the data. That's what I call drill through. So. All right, and then finally, we could talk about things like scenarios and changing dimensions, which would take us into the weeds a little bit. But Kimball does a really good job of exploring those concepts and talking about how you design for them. So that's it. I appreciate your time, and I'm available to answer questions afterward. You can reach out to me.